Today we are going to discuss one of the most vital topic in Java, that is encapsulation. Encapsulation is the first pillar of object-oriented programming. It is the art of shielding your data from the outside world. If you want to write professionally, secure, and bug-free code, you must master this. Let's dive in. So, what exactly is encapsulation? If you look into the word, you can see capsule. Think of two things happening at once. First, the wrapping effect. We are bundling variables, the data, and our methods into a single unit called the class. Second, it leads to data hiding. We are intentionally hiding the internal state of our object so that the outside world can't see or touch it directly. In a professional environment, we never want our data to be naked or exposed. The best way to remember this is to think of a medical capsule. Look at the image on the left. The medicine inside the powder or the liquid is the sensitive data. The outer plastic shell is the class. If you want the medicine to work, you don't open the capsule and pour the powder into your mouth. You swallow the whole capsule. In Java, you don't touch the private variables inside the class. Instead, you interact with the shell, the method, to get the job done. The shell protects the medicine from the environment and it protects the environment from the medicine. Now, why do we bother doing this? Why not just making everything public? Think of a bank account. If the balance variable is public, any programmer could accidentally write the balance as minus 5,000. That would break the logic of your bank. Encapsulation provides controlled access. It's like a bank vault. You can't just walk in and grab cash. You must go to the teller, the method, provide your ID, and the teller moves the money for you. This prevents data corruption and gives you the flexibility to change the internal code without breaking anyone else's program. To achieve encapsulation in Java, we follow a simple two-step formula. Step 1, private fields. We declare all our class variables as private. This effectively locks the door. Step 2, public methods. We provide public getter and setter methods. These act as a secure, controlled windows that allow the outside world to view or modify the data, but only on our terms. So here is the private keyword. This is an access modifier that says this variable can only be seen by the code inside the specific class. A private member is invisible to other classes, even though these are in the same package. This creates a contract. If another class wants to see the data, it must ask the owner of the data through a public method. Let's look at our windows, getter and the setter. A getter is also called as the accessor, is used to read the value. It usually starts with the word get and returns the variable type. A setter, also called as the mutator, is used to update the value. It usually takes a parameter and sets the private field to the new value. Look at the code at the right. Set age, int a, takes an integer and assigns it to the internal age. This is the point where we can add security checks. When writing setters, you will often run into a naming conflict. Look at the code at the bottom. The method parameter is named age, and our class variable is also named as age. Java gets confused. We use the this keyword to solve this. This refers to the current object. So this dot age means the variable belongs to this class, while the plain age refers to the temporary value coming into the method. It's a way of saying take this input and put it into my storage. Let's walk through this code line by line. First, we have private double balance. No one can see this information outside the account class. Next, look at the deposit method. It's public, so anyone can call it, but look at the if statement. If amount greater than 0. That is the bouncer at the door. If someone tries to deposit a $1 million, the bouncer stops them and the balance remains same. Finally, the get balance method allows the user to see their money, but they can't change it through this window. This is a perfect encapsulation. This leads us to the biggest advantage, validation. Think of a setter as a security guard. In a procedural programming, anyone can walk through the gate. In an encapsulated program, the guard checks your ID and your luggage. If a user tries to set their exam marks to 150, your setter can catch that error because it knows marks can only be between 0 and 100. It rejects the bad data before it can even touch your private variables. Don't fall into these traps. The first is blind getter and setter. Don't just auto generate them for every single variable. If a value should never change, like date of birth, don't give it a setter. Second, avoid public fields just to save time. It's tempting, but it's destroying the security of your object. And finally, always add logic to the setter. A setter without a if statement is just a public variable with extra steps. To wrap up, here are your exam and interview tips. If your examiner asks for a one line definition, say encapsulation is wrapping data and method into a single unit to ensure data hiding. And if they ask what is the difference between abstraction and encapsulation, give them this simple answer. Abstraction hides complexity, how it works, and encapsulation hides data, what it knows. Thank you for your time today. In our next session, we will see how we can use inheritance to reuse the reality we have built. Happy coding!